All right, guys, here we go. This is from the 2021 exam. So let's do this one together. Check it out. No calculator. So let's read it together and see what this says. A company designs spinning toys using the family of functions. Okay, that's cool. Where C is a positive constant. The figure above shows the region in the first quadrant bounded by the x-axis and the graph of y equals cx squared of 4 minus x squared for some C. Each spinning toy is in the shape of the solid generated when such a region is revolved about the x-axis. Yeah, I've seen that toy. You've seen it too, right, guys? Like they spin it with a string and it just spins. It spins at that end there. It's at the side at the moment, but have you guys seen that toy before? Yeah, this is three-dimensional, and they rotate it from that's like a disc there. You have no idea? Yeah, well, do a YouTube in a little bit so you can see the toy that I'm talking about. I don't know what the name of it is, but we'll see. All right, here we go. Each spinning toy, we already read that, right? Both x and y are measured in inches. Okay, let's see what it says. First question. Find the area of the region in the first quadrant bounded by the x-axis and the graph y equals cx squared of 4 minus x squared for c equals 6. Okay. So that means I have an equation. Here's my equation. 6x square root 4 minus x squared. That's going to create some type of curve, more likely something similar to this. Depending on the c value, it's going to change, how high it goes and all that good stuff. But they want area under this curve. So let's see. What do I got to know? Where does this equal 0? I don't have a calculator. You don't have a calculator. I know that this equals 0 at 0. And how do we calculate that 0? Oh, I don't know how to do that. Not plus minus -2, just 2. You're not gonna say -2 because I don't have anything over there. All right. How did I get this 2? In case you're wondering how I got that 2, you got that 2 by looking at 4 minus x squared. What does that equal 0? Well, that's only going to equal 0 if x is 2. 2 squared is 4. 4 minus 4 is 0. If you don't see that, just set the expression equal to 0 and solve for x. Square root of 4 is 2. Do you guys see that or no? Okay. All right. Next. Here we go. Integral. From what to what? 0 to 2 of 6x square root of 4 minus x squared dx. Are we okay still? All right, next. Well, we're going to have to integrate this. Look at it. Is there a way to take the antiderivative of that? And what did you learn? Like, what skill is it? Or what do I do? Or what? Chav, it's not possible to do the antiderivative. I need a calculator. Well, we have no calculator. So how are we going to do it? U sub. Tell us, Salali, why did you say U sub? Yeah, guys, this is a quadratic, 4 minus x squared. When you take the derivative of that, you'll get a linear. Do you guys see that? So here it is. Whatever's in red means it's still the original. If you have colored pencils, it is a good place for colored pencils. I'm going to write it like this. I'm going to go 6 on the outside. And at the moment, it's still 0 to 2. And I'm going to go u equals 4 minus x squared. Du equals negative 2x dx. So that means I need a negative 2. So I'm going to put a negative 2 in there. So there it is, negative 2. And then x square root 4 minus x squared dx. If I put a negative 2 there, I need a negative 2 in the bottom. You could have also factored out like a negative 3 and then put a negative 2 in there. Negative 3 times negative 2 is a positive 6. But it's not a big deal. Or does this make sense so far? You could have. You could have put a negative 3 on the outside and then negative 2. And then negative 3 times negative 2 is 6. Notice that 6 divided by negative 2 is still negative 3. All right. Are we okay so far, guys? All right, here we go. Negative 3 integral. I'm going to have new limits. The negative 2x dx is du, but put it at the end. And then the 4 minus x squared is u, but I'm going to write the square root. Instead of a square root, I'm going to write an exponent. U to the 1/2 du. When x is 0, plug in that 0 right here, guys. When x is 0, u is 4. And no yawning, that's a demerit. When x is 2, u is 0. 2 squared is 4. 4 minus 4 is 0. And it's just begging me. Well, it's not begging, right? Because it doesn't talk. But it feels like it's begging me to switch these limits because I have a negative on the outside. When I switch the limits, it turns to a. There we go. And now we're not going back to our x, guys. That's bad news. You're just going to solve for this one. And whatever the answer is, that's your answer. So here we go. 3. That 3 is this 3. Times antiderivative of u to the half is u to the 3 half divided by 3 halves is the same as multiplying by 2/3. I write a line that stands for evaluated at. Lower limit 0, upper limit 4. The 3's cancel out. And I guess you don't even have to worry about that 0 because 0 or anything is 0. So I'm going to write 2 parentheses 4, close it to the 3 halves, equals, and now just a little bit of arithmetic. By the way, you can leave it like this if you're scared. Don't be scared. I believe in you guys. The square root of 4 is 2. 2 to the 3rd power is 8. 8 times 2 is, there it is, 16. Done. Cool or not cool? Okay, go to the next one. All right. What do you think, Kundur? But is it making sense? Okay, well, that's what you got to ask me, miss. Where did I lose you? Because you were on your phone, miss. You got to focus. All it asks is for the area of that under that curve. So I just did integral from 0 to 2. Those are my limits of that curve. Where did I get the 2 from this? What makes it equal to 0? Well, if the square root of 4 minus x squared is 0, 4 minus x squared equals... Well, yeah, isn't that the y value of 0 when I'm down here? Yeah, see? Okay, focus, miss. You can do it. I know you can. All right, letter B. Let's see what it says, guys. All right, focus, guys. Focus, focus, focus. It is known that for y equals cx squared of 4 minus x squared dy dx, so they give you the derivative, for a particular spinning toy, the radius of the largest cross-sectional circular slice is 1.2 inches. Underline the word largest. What is the value of c for the spinning toy? Guys, so they're telling me that the largest slice, the largest cross-section has a radius of 1.2 inches. The largest looks to be about right there. Do you guys see that? Okay, think about it. They give you the original equation and they give you a derivative. We can create a system of equations by doing this. How are we going to find it? This largest point on the curve, right there, at that moment, the derivative is 0, right? So I go from a positive to a negative. Do you guys see that? That's a definition of a max, wherever the derivative changes from positive to negative. So you get a point, and I know because I already looked at the rubric, but this morning. But in a little bit, I'll show you the rubric. So guys, first you do this. You set your derivative equal to 0. And you know that the biggest radius is 1.2 inches. That's your biggest radius, 1.2 inches. Well, that's just a y value, right? So that means I'm going to set this guy right here equal to 1.2. I'm going to get the x value. Child, how are you going to find an x value? I'm going to find the x value by setting the derivative equal to 0 and solving for x. And once I find that x value, I'm going to plug it in here. And then I'll solve for c. That's a system of equations from your algebra 2 days. Wake up. Sorry, miss. Does that make sense? All right, so here we go. I'm going to set my derivative equal to 0. So c, parentheses, 4 minus 2x squared close equals 0. Child, how come you don't worry about the denominator? Guys, the only way to get the derivative to equal 0 is if the numerator is 0. What's up, Delani? Tell me. So there it is. I set my numerator equal to 0. Okay, guys, how can I get this to equal 0? Well, C is 0, but that doesn't make any sense. I'm solving for C. How can I get C equal to 0 if this expression is supposed to equal 1.2? So that's silly. Do not set C equal to 0. But this right here, set that equal to 0, because 0 times that is 0, right? So 4 minus 2x squared equals 0. Move the 2x squared. 4 equals 2x squared. Divide by 2. 2 equals x squared. Take the square root. Square root of 2 equals x. Now that I know the x value, and I'll slow down. Now that I know the x value, I'm going to insert that bad boy right there.
Wait, why did you say we got rid of C again? Just because it's a number, so thank you.
No, we're looking for C. It doesn't make any sense for C to be 0 if that's what I'm looking for. There's no way that I'm going to be able to get y to be 1.2 if C is 0. So that it would be silly to say, oh, C is 0. It's not. Do you know what I mean? Because I need to get that 1.2, and if C is 0, that would be impossible to get 1.2 out of that.
That's what I was saying. I was like, it's a number, so you just get rid of it.
I didn't get rid of it. I just said C cannot be 0, so I just focused on the 4 minus 2x squared. Because that has to be 0, because my derivative is 0. You know what I mean? We're looking for the value of C. We don't know the value of C, so we find it.
What does it mean? Just a number?
It's just a number. A number that creates, any number of C will create different variations of how tall this is or whatnot, Like it's a vertical stretch. No, C is just a number. The y value is 1.2. Yeah. So here we go. 1.2 equals C times square root of 2 times, that's a C, not a parenthesis, square root of 4 minus, I guess I'll write it in here, square root of 2 squared. I was just going to write 2 there. Square root of 2 squared is 2, and 4 minus 2 is another square root of 2. So 1.2 equals C square root of 2 times square root of 2. Are we still okay? Square root of 2 times square root of 2 is 2. 1.2 equals 2C. So then I divide both sides by 2, and you get 0.6. Not everyone at the same time. How are we feeling, guys? You don't like it? Okay. Tell me.
Okay, wait. Tell me again why we got the derivative.
Because that's where I have the biggest, that's where I have the max. And look what they told me. If I want the largest, that's wherever the derivative goes from positive to negative.
So we do that the max, but we're trying to find C, which is in the equation.
Yes.
Okay.
Letter C. All these C's here. All the C's. For another spinning toy, the volume is 2 pi cubic inches. What is the value of C for this spinning toy? Okay, you guys ready? So they're testing us. Let's see, do we have a letter D? Nope. For another spinning toy, the volume is 2 pi cubic inches. What is the value of C for the spinning toy? All right, guys, if I rotate this about the x-axis, here's my spinning toy. I didn't draw it super awesome. That's fine. Because that's my toy. This is what I'm trying to find the volume of. Oh, there we go. This is what I want the volume of, right? Yeah. All right, here we go, guys. Here's my slice. All right, focus, guys, focus. I know it's late in the day, but focus. There's my slice. What shape is that? A disc. A circle. So here we go. The radius is the distance from this to that curve right there. And that curve is this one, that equation right there. So I'm going to go volume equals pi on the outside, integral from 0 to 2, open parenthesis, cx square root of 4 minus x squared, close squared dx. Pi r squared. There it is. Yes, that's my radius. No, because of this. See the disc? See your cross section? Yeah, that's a curve. Yeah. Okay. Yeah. Or I mean, you can write -0 if you want, but you don't. Yeah, be silly. Okay, there it is. Can we do this? They're trying to see if you know how to do the antiderivative, guys. So here we go. On the side, focus, guys, focus. On the side, we're going to go ahead and expand it. So when I expand it, here we go. C squared x squared, and then 4 minus x squared. Do you guys see that? The c is just a constant. Well, okay. I was going to leave it there and just distribute the x squared, but okay, now I'm just going to distribute the x squared. No, I don't want to confuse you guys. 4c squared x squared minus c squared x to the fourth. What? I just distributed.
Oh, I see what you did. Everything?
Well, I was going to distribute just the x squared and just factor out, put the c squared on the outside. But I lost people last time, so maybe this will work. Or maybe, I don't know, maybe I'm making life harder. You see how I have a c squared on both of these terms? I didn't have to distribute it, right? I could have just left it like this. That's what I should have done the first time. Okay, sorry. All right, here we go. I'm plugging it back in, guys. Volume equals pi c squared integral from 0 to 2 of 4x squared minus x to the fourth dx. Have I confused anyone? All I did was law of exponents and squared everything that I had. It was a product, and I just squared everything. Cool or not cool? Yeah, it's a constant. It's all being multiplied. All right, here we go. Pi c squared, that's just that. Antiderivative of 4x squared is 4x cubed over 3. Antiderivative of x to the fourth is x to the fifth over 5. Lower limit 0, upper limit 2. I do not have to worry about the 0, but I do got to worry about the 2. Pi c squared, bracket, 4, 2 to the third. 2 times 2 is 4. 4 times 2 is 8 over 3 minus 2 to the fifth power. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. Yeah, you got to do this without a calculator, guys. See, they're testing you. And it's not gonna be arithmetic that is extreme. So here we go. And yeah, they're forcing you to do this because you got to solve for c, right? And we know that the volume better be equal to 2 pi. So once we get all this, we're going to just equal it to 2 pi. So here's what I have. Let's see. Pi c squared, bracket, 4 times 8, 32. And then 32 times 5, 36 to 90, 120, 2, 4, 6, 8, 10. Yeah, 160. 160 over 15 minus 30, 60, 90, 2, 4, 6, 96. I'd have to do it in little pieces. And let's keep going. Pi c squared, bracket, 160 minus 96, 60, 64. 64 over 15. So 64 pi c squared over 15. I know you can reduce it. Actually, no, you can't right now. Okay, I'm going to equal this. Yeah, I'll wait. Semicolon. I'm going to equal this. This is my volume. Look what it says there. That's volume. What did they tell me my volume was? So I'm going to go 64 pi c squared over 15 is equal to 2 pi. And I'm going to solve. I'm going to solve for c. So I'm going to multiply this. Let's see. What am I doing first? Pi's cancel out. Multiply by 15 over 64. Multiply by 15 over 64. So here's what I have. And I'm going to write it over here in the open space. C squared equals 2 times 15 is 30. 30 over 64. That does reduce, but I'm not going to reduce it. I'm not reducing it because when I take the square root, the square root of 64 is... So I'm going to leave it like c equals square root of 30 over 8. What do you guys think of this question? What year was this? 2021. Okay. I did not save it, and that's what I did it this morning too. Let me go ahead and look up the rubric for this. This one's going to be a very detailed rubric. 2021 scoring guidelines. All right, here it is, guys. Here's my rubric. Letter A was worth 3 points. Did we get, 1 point for the integrand? Did we do area 0 to 2, 6x squared to 4 minus x squared dx? Yeah, look, they give you a point for the integrand. All right, guys, come on, focus, guys, focus. Letter B, did we do the antiderivative correctly? Yep, and then letter C, the answer. We didn't write 16 square inches. It would have been nice if we would have written that, but I think you're still good because it didn't say anything about saying the units and all that good stuff. And there it is, 3 points. All right, let's go to letter B. And here, guys, oh my God, I love this. No, look, let's say you didn't know how to do any of it, but at least you did this. At least you set the derivative equal to 0. They'll give you a point for that, guys. If you just wrote dy dx equals 0, that's a point. Look what it says right there in that first bullet. The first point is earned for setting dy dx equals 0. This is my derivative, so it can look like this, it can look like this, or it can look like that. Any one of those three, you would have gotten a point.
So if we don't put dy dx equals 0, we just put
no, it depends. It depends.
Wait, no, that's not so. You would have to do that last one in order to solve for it anyways.
As long as you have the equation equals 0 somewhere to solve. Let's say, look, it even says right here. Let's say you would have solved for x, and you would have gotten the right answer. An unsupported x equals square root of 2 does not earn the first point. You wouldn't have gotten the point. So sometimes it's called a bald answer. Like if you found x equals square root of 2, it's called a bald answer because where did that answer come from? It came from setting the derivative equal to 0, but you didn't show that. Do you guys know what I mean? Okay, and then look, and then we got the point. So this one was worth 2 points. So if you got the answer without showing the first one, you probably did not get the answer one. This is why I tell you guys all the time, show your work. Show your work. Mata, show your work. You don't have an issue. I just looked your way and you were looking over here. So. All right. Cool or not cool? Kinduru, cool? All right. Let's look at letter C, guys. Look at that. Oh, wow. Look. Okay, hold on. Did we get the point for the answer point? No, we got it. You don't think we did? This is the same as our answer. It's just that this is not, they reduced it, remember? Okay, look, I want you guys to know this for a fact. So look, check it out. I know, guys, I know you guys are tired. Square root alpha y equals, what was it, 15 over 32? 15 over 32. Enter. Look at that. We got square root of, what do we get? Our answer? Square root of 30. Square root of 30 over 8. Square root of 30 over 8. It's the same, guys. We got the point. It doesn't have to look like the rubric as long as it's the same value. And there it is. What did you guys think? Cool or not cool? All right. Do we have the energy for another one, guys? Okay. This one is calculator active. So you need your calculator. Do you guys want me to give you guys a head start, see if you guys can do it or no? Just go right into it. Okay, let's go right into it. Calculator active. Question 2. Take your calculator out. Let f and g be the functions defined by f of x equals ln of x plus 3 and g of x equals x to the 4th plus 2x cubed. The graphs of f and g shown in the figure to the right intersect at x equals -2 and at x equals b, where b is greater than 0. Find the area of the region enclosed by the graph f and g. Okay. If it's calculator active, you just got to show them the setup of how you got all the values. First thing I would do, I need this answer, which I already know that's just -2, but I need this one where they intersect. That they're calling it B. So how do I get B? Like this, guys. You're going to go ln of x plus 3 equals x to the fourth plus 2x cubed. So that is only equal, it's equal in two locations. It's equal at x equals -2 and at x equals b, which equals, and I'm going to give the number in a little bit. So I take my calculator. I hope it's still here because we did it this morning. Nope. Okay. What is it? ln of what? X plus 3. And what was the other one? X to the fourth plus 3x cubed. 2x cubed, like that. Okay, window -2 to 2. -2 to 2. I don't remember the exact window. I would have to look at the that's good enough. Let me go a little bit. That's fine. That's good enough. I need this intersection right there, guys. I need that intersection right there. Second, calculate number 5. Enter, and then scroll to the closest one. The one that you want. 0.7819751. 0.78. I already forgot it. 0.78197751. Okay, there it is, guys. Store that in B in your calculator. Second quit, X, store, alpha B, and make sure that it says that same number. Are we okay so far, guys? All right, here we go. The area. This graph, make sure you know which graph is which. That graph is f of x. This graph down here is g of x. And here we go. Area equals integral from -2 to b. And then what graph was on top? F of x. Graph on the bottom, g of x. dx. You don't have to put parentheses like that if you don't want to. And now type it in the calculator. Oh, that's good stuff right there. Type it in the calculator. I'm going to go home screen. Math 9. -2. Hey, no yawning. Alpha B. Alpha trace y1 minus alpha trace y2. And x. Enter. 3.603 or 3.604. I'm going to say 6035. 3.6035. You can round it because of that 5. You can round 4 if you want. I just like to put digits. How many digits after the decimal minimum? At least 3. At least 3. Okay. Next one. Between -2 and b, let h of x be the vertical distance between the graphs of f and g. Is h increasing or decreasing at x equals -0.5? Give a reason for your answer. Okay, let h of x be the vertical distance between the graphs of f and g. Okay, here's my line. -0.5 is probably like right here. It looks like it's decreasing because this graph is going up faster than the other one. So that's h. So h of x is equal to f of x minus g of x. Is everyone okay with that? All right. How do I know whether it's increasing or decreasing? How do I know when anything is increasing or decreasing? Take a what? Take a derivative. If the derivative is positive, it is. If the derivative is negative, it is. Oh, guys, come on more alive. YouTube's going to think that I don't even have a class. Let's do that one more time. If the derivative is positive, it is. If the derivative is negative, it is. Okay, good. That sounds better. Guys, you have to show nothing. You just got to show the setup. Is this a calculator question? So all you got to do is go like this. H prime of -0.5 equals, if it's a calculator question, you just got to show the setup and that's it. So here it is. Go to the calculator. I'm going to go math and then look for the derivative one, number 8. ddx. And I'm just going to type in alpha y1 in here minus alpha y2 in here. And then at what value? At negative what? I got -0.5999999. Notice all those 9s. If you are paranoid, you can just type -0.59999. But because of all those 9s, I can just say what? -0.6. If you're paranoid, go ahead and put -0.5999. You're fine. -0.6. Because I got a negative value, what is H? What's happening to H? There it is. I'm going to say H is decreasing at x equals negative 0.5 since H prime of negative 0.5 is negative. There it is, full credit. H is decreasing at negative 0.5 since H prime of negative 0.5 is negative. Boom. Two booms. Boom. Boom. Actually, that was more like 4 booms because I went with both. I'll stop. All right. Letter C. The region enclosed by the graph of f and g is the base of a solid. Cross sections of the solid taken perpendicular to the x-axis are squares. Find the volume of the solid. I love it, guys. Okay. It's coming out of the board. It's perpendicular to the x-axis. It's coming out of the board. Hey, that's not yawning. I'm going to write a numeric for everyone right today. All right. So, look, it's coming out of the board, guys. So, how do I find area of a square? Side squared. Just side squared, right? Because all the sides are the same. And how do I add them all up? How do I add infinite amount of cross sections? Do a what? Integral. So there it is. If I want the volume, there it is, guys. Volume. Volume equals integral from what to what? Negative 2 to b. As soon as you identified what b is, I'm not saying like the censored version of b. We're not talking like that. It's this b. As soon as you identify what b is up here, you can use b all over the place. Do you know what I mean? You can use b all over the place. All right, so here it is. So negative 2 to b, and then parenthesis, my upper curve was f of x. My lower curve was g of x. Close it, square it. Chop, why is it squared? Area of a square is side squared. That's one of the sides, and it's coming out of the board. Does that make sense or no? That's one of the sides, and it's coming out of the board. This is f of x minus g of x. And this side must be the same side. Must be the same height. F of x minus g of x. All right, take the calculator. And this is why it's a calculator question. So this is a calculator question, right? Yeah, calculator active. So here we go. Math 9. Guys, make sure to practice with me. Negative 2 to b. Open parenthesis, alpha trace y1 minus alpha trace y2. There it is. 3.6035. Oh, did I not put the square? Yeah. We got the same answer as before. What's going on, miss? Oh, just put it like on the door there. Second, insert parenthesis. And then right here, and then put a square. Hold on. 5.3401. Hopefully I didn't make any mistakes there. 5.3401. 5.3401. All right. All right, guys. Last question here. A vertical line in the XY plane travels from left to right along the base of the solid described in part C. The vertical line is moving at a constant rate of 7 units per second. Okay, slow down. Do we know what's happening? You just have a line. I don't know, maybe it's a barcode or something like, and it's moving left to right at this speed. So that's the XCT right there. So a vertical line, so just some random vertical line. I'm going to write it here in blue. So boom, some vertical line and just moving left to right. Vertical line and the XY plane travels from left to right along the base of the solid described in part C. Okay. The vertical line is moving at a constant rate of 7 units per second. Find the rate of change of the area of the cross section above the vertical line with respect to time when the vertical line is positioned negative 0.5. Okay. So what are they saying? Here's what they're saying. I love it. I hope you love it. Read it again if you don't get it, guys. You have a vertical line. Yeah. You have a cross section here. So right at negative 2, you don't have a cross section just yet because both points intersect. But as soon as you get out of there, you have a cross section and it's coming out of the board. It wants to know the rate of change of that area. That's what it wants to know. Does that make sense? It wants to know like how fast is the cross section get, like the rate of change of the cross section area as it gets bigger. Obviously, it's biggest like right here somewhere, and then it gets smaller. But it wants to know the rate of change right at negative 0.5. Does that make sense? If I want to know the rate of change of the of the cross section of the area, what do I got to do? Take a what? A derivative. Yes. So check it out. My area formula is just f of x minus g of x. Sorry, guys. With a square on it. This is my area formula. I'm going to take the derivative because I want to know the rate of change of my area. Yeah. What's the derivative of this? I'm taking the derivative with respect to what? Yeah, t. Here it is, guys. Ready? dA dt equals what? 2. Leave the inside alone. Times what? The derivative of the inside. But remember, what am I taking the derivative of this with respect to what? So I'm going to write f prime of x, and then right next to it, I'm going to put dx dt minus, because that's a minus there, minus g prime of x, and then right next to it, I'm going to put what? dx dt. To make calculations easier, I don't want you guys to get confused. You see how there's a dx dt on both of these? I'm just going to factor it out just to make my calculations easier. So I'm going to write dA dt, evaluate it at, and you don't have to show anything out. You don't have to show anything. This is just for your notes, guys. dA dt evaluated at x equals negative 0.5 is, and here it is. I'm going to take my calculator, and I'm going to, okay, you know what? Let me factor it out here right now so you guys don't get confused. Factor it out. dx dt. There it is. I'm going to erase the factored out. So there it is. I'm just going to plug it into my calculator, guys. I'm just going to plug it into my calculator. Chav, what do you mean? Like this. 2 parenthesis alpha trace y1 at negative 0.5 minus alpha trace y2 at what value? Negative 0.5. Close a parenthesis. There's my first one. Times, open parenthesis, math number 8. Be careful. Be careful on this. Put x there. Do not put y1 at 0.5. Just put y1 minus y2. Alpha trace y1 minus alpha trace y2. If you put y1 parenthesis of negative 0.5, then you're just going to do the derivative of a constant, right? And the derivative of a constant is 0. Because y1 and negative 0.5 means y1 evaluated in negative 0.5. Yeah. And then now here, that's where you put the negative 0.5. Negative 0.5. Close the parenthesis. Let me get out of there. There it is. And then last thing but not least is multiply by what? By 7, my dx dt. Yeah, that's why we factor it out to make it easy. See, that's why I didn't want to put the 7 in there. I guess you could have, and it probably would have been the same. But there it is. Negative 9.27184.
What's up, guys? It's Baddie Aguilar back for second round, second semester. Okay, let's start with number 3. Let R be the region in the first quadrant and close by the graphs of y equals 2x and y equals x squared, as shown in the figure in the right. So we're gonna find the area of R. So, well,
Click on the red. There you go.
Okay, there we go. R. Whoa. Oh man.
You can erase it by like a pencil. Yeah.
Okay. R equals so we have to integrate it. We're gonna integrate it from 0 to 2 because these are intersection points. And then the upmost function is 2x. Y equals 2x. This one over here is y equals x squared. So we're gonna do 2x minus x squared dx, and we're gonna have, when we find the derivative of that, or the antiderivative of that.
Yeah, you're doing good, miss. I'm just gonna zoom in really quick.
Okay. Oh, that's nicer. Yeah. Okay. It's x squared minus x to the third over 3. Just doing power rule. I'll evaluate that at 0 to 2. And we don't really need to do 0, just 2. So that is 2 squared minus 2 to the third over 3, which is just 4 minus 8 over 3. And we could leave it like that, but we could simplify that. So we just times this 4 over here by 3 to get a common denominator. And that's 12 over 3 minus 8 over 3, which is 4 over 3. So yeah, and make sure to get the point. We're going to put r equals 4 over 3. Okay. So B. The region R is the base of a solid. For the solid at each x, the cross-section perpendicular to the x-axis has an area ax equals sine pi over 2x. So find the volume of the solid. We already have our area right here. We're just going to do volume equals, do an integral. We're going to go from 0 to 2 because we went from 0 to 2 over here. Same thing. 0 to 2. We're going to go sine of pi over 2 of x dx. And then we're going to find the antiderivative of that, which is negative cosine x over 2, or pi over 2x. And then we're going to just times that by the reciprocal because it's inside of the function. So that just becomes negative 2 over pi cosine. And then we're going to evaluate this at 0 and 2. We don't have to do 0, so we're just going to do...
You do have to do 0.
Oh, dang it. Yeah, okay. We have to do 0. We're going to do... Oh, we could factor this out since it's kind of just like a constant. Negative 2 over pi cosine pi. We get pi because when we do cosine of 2, yeah, it just gets crossed out. And then for the second one, that's just cosine 0 because anything times 0 is 0. And that's going to be negative 2 over pi. This is negative 1. This is 1. So minus 1 equals negative 2 over pi times negative 2, which is 4 over pi. And make sure to put volume equals 4 over pi. Okay, so the last one, another solid has the same base R. For this solid, the cross sections perpendicular to the y-axis are squares, right? But do not evaluate the integral expression for the volume of the solid. So we're going to have to take our equations, which are y equals 2. Y equals 2x, and just, get x alone. So divide by 2. We have x equals y over 2, and that's this one right here. X equals y over 2. Then we have the other one, y equals x squared. Y equals x squared. Square root that. Square root of y equals x. And that's this one right here. Okay. So when we're finding the area, or volume, when we're finding the volume, we're going to do our integrand, and we're evaluating it from 0, because the intersection is right here, to 4, since we're doing it in terms of y. So 0 to 4. And it's different than when we're looking at x. We're looking at the rightmost as like the larger one. So that's going to be square root of y. So we're going to do square root of y minus y over 2. We're going to square that because these are squares. The cross sections are squares. So when you're finding the volume of a square, it's just side side times side or side squared. And then close out with the dy. And then, yeah, that's it, right?
Hey, miss.
Mm-hmm.
Yay.
Yay.
Thank you, miss. Appreciate you.
No problem. Do you like my intro again?
Yeah, that was good. That was good.